CSE 3200 Yukon stores. We're in Chapter 25, Animations, and we're in video 2. In our last video, we basically set up our view here. We put in some custom colors. We put it in a custom shape, which is going to act as our sun. And we talked a little bit about the view and how it's working with the weight and the frame layout. Okay, well today we are going to get our animation going. So we're going to go into our main activity and we are going to set up our view binding. We've already done this in the Gradle. We're going to go private late init binding of type activity main binding. Okay, I forgot var. Activity main. Do I get autocomplete now? Sure I do. All right, we comment this out. We're going to be setting up our content view a different way. We're going binding is equal to activity main binding dot inflate. And we're going to put in a layout inflator in here. And then we're going to go set content view, passing in binding dot root. So I'm going to grab this much. Okay, binding is all set up. Now we are going to make a function called start animation. Private fun start animation. No parameters, and do have curly braces. In our onCreate, let's call our start animation, and let's do that whenever we click. So let's go binding dot set on click listener. I expected an autocomplete there. Okay, so let's see. I'm missing a word. I remembered it after I typed it. If I go back to activity main, the entire layout has an ID of scene. So we are going to put in binding.scene.set on click listener. All right, so now we'll call start animation from there. And it's great. We have a listener, but it doesn't do anything. So we are going to start with declaring where we're going to start and end our animation. Val sun y start. I'll just go 0 for now. And val sun y end is also equal to 0. So it's going to start at 0, end at 0. Great. But that's not really what I really want. I just wanted to get to the next line. So this first one, sun start y, we are going to start from, let's go to our activity main. And you won't be able to see me, but give me a second here. I'm going to pause this. OK, so we are going to start this here. It's only about animating on the y coordinate. And then we're going to end it someplace. So we're basically going to take any one point on the circle, say that point, and we are going to translate it down at a fairly consistent interval, at least at first. And we're not in charge of this math. I'll show you that in a minute. But we're just going to go move, 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 move in a way that looks like a smooth transition. And we just need to get this point down here below the line anywhere. So let's see if I go back to the main activity. We're going to set the sun y start to binding dot sun dot top, so the top of the sun, but we're going to change that to a float value. Okay, so that means that this is going to be our starting value for our y, anywhere on that horizontal line, because y is only taking into account one of the two coordinates on our two-dimensional coordinate system. Our sun y end, the book has this going to binding.sky height to float. Okay, here's how that's working. The height of the sky. This sky starts here, and let's just say that this is 0. And the sky ends here, and let's just say that that's about 400. I know that I put in hard-coded 500, and it looked like it fell about there. So I don't really care what it is, but 400 is a nice simple number. Okay, in order to get the sky's height, what it's going to do is just do the subtraction here and say that the sky's height is 400. And so it's going to take the y value from where it is now to 400. So it's going to take this point and it's going to translate it to right there. And so I guess the sun would end up right there. And it would turn out to be invisible. So that's how it's going to work. And we are not going to get to see it move until we set up an object animator. Let's do that. Val height animator is equal to an object animator. And we're going to autocomplete and get our import. And we are going to go dot of float. And we are going to put in a couple of arguments, binding dot sun. So what are we moving? We're moving the sun. That is our first argument. What property are we changing? We're going to change the y property. Where are we starting? That's going to be sun y start. Where are we ending? That is going to be sun y end. Okay, now I could hit run right now, but that still doesn't do anything. We've got our on-click listener, which would start the animation, but we actually need to fire this up. We need to say height animator dot start. Now we're going to run it. The sun has fallen off out of the sky here. I hit run. I do have an error, but take a look at this. I'm going to run it, and it goes super fast, super fast. Now, I forgot to say how long we are going to be animating this. So we're going to go in here. We're going to go dot duration. Passing in 3000, dot set duration, passing in 3000. That'll give us a 3-second animation. I'm going to talk while this is booting up. So when I make animations in the past, or have made animations in the past, I have been in charge of how smooth it is by setting up the delay and the increment. That is not happening here. This is going to be a nice smooth transition. It's also going to be a nice smooth translation. Translation is a slide, and I'm going to hit anywhere, and we have ourselves a nice sunset. So what's happening here is that it says I've got this starting spot, right? And I've got to get from there to, say, there. And I need to do that in 3 seconds, and I need this to be smooth. So let's get this up here. Where did you go? Okay. So I need a nice smooth translation. So it's just taking those 2 points and it's saying I've got a certain amount of time to get there. So we're just going to figure we're going to keep moving at such and such a pace. So this animator is doing all of that work behind the scenes, saying how fast it is, how fast it's going to move based off of how far it's got to move and in what time. So it is taking that data and it's interpolating it. There are other interpolators that you could use. The book shows one here, and I think it said that there are like 2,000 or so different interpolators that you could take a look at. But here's one that the book puts in. Height animator dot interpolator is equal to an accelerate interpolator. And we'll put some parentheses there. And did we get an import? We did. Okay, so you have to see this. I don't know, you have to pay attention to it. It is may not be that obvious, but if I tell you what's happening, maybe you'll figure it out. If you've read it already, maybe you'll figure it out. So let's run it a couple times. Okay, let's run it one more time. All right, so it takes a while before you can see it, but it starts off by moving slow, and then it speeds up kind of like a ball being tossed in the air. The ball is going to go up and decelerate till it gets to a certain point, and then it will start to go in the opposite direction, but slowly until it's going to hit terminal velocity or hits the ground or something like that. All right, so that's what that interpolator does, is it just basically is going to do the math in a slightly different way to have an effect of acceleration. All right, so we are going to end video 2 right there. We have a pretty nice smooth transition. It's a translation, just a slide in just the y on the y-axis. Next up, we are going to get our sky to change colors. See you in that video next.